Hello class, this is the last example for the sum, difference, and product of two functions. And here are the two functions we're going to be applying it to. You'll find that functions that have asymptotes, like this one here, that it gets a little bit more tricky in that, there's a lot more things to consider, since these rules or these guidelines, they actually don't give as many points to graph when it comes to functions with asymptotes. So you can pause it and give it a go yourself, but you can work along as I do this first example here. So let's try and apply as many of these as we can. Let's find points where the two functions intersect, where they are equal to one another. I can see two straight away, one here, and one here. Oops. And where they meet, since we're adding them to each other and they meet, it's as if we're doubling those lengths. So there's one and there's two. So we already have 2 points that we can work with. Let's move on. Let's find points where f is 0 or g is 0. So points where f is 0, I can see one here. And now 0 plus whatever g is, 0 plus anything, is that anything. So 0 plus g is just going to be g. There are no intercepts here, no next x intercept, sorry. So we can ignore this point here. And lastly, when g is 0, so 0 plus anything is that anything. But notice how at 0, that's actually where the asymptote is. So we actually can't plot where f is at that point. Okay, so we can't use this anymore. Now let's do one last thing here. Now this one, you'll find as I'll take you through it, we actually can't apply here, because if we try and look for any, we won't be able to find any. I'll demonstrate. Let's consider this point here. Remember, f of a must equal negative g of a. So let's take, for example, this point here is, let's say, positive 1.5. For there to be an x-intercept for the sum, this has to be negative 1.5 for g. But notice how they are both positive. Well, since they're both positive, it's impossible for f to be negative of negative g, since they're both positive. So we actually can't apply it on this side here. There are no x-intercepts on the right-hand side, meaning the curve that we're about to draw doesn't do something like this. There are no x-intercepts. Let's get rid of this. Now for this left-hand side, let's consider the first bit of logic that we have to think about. Let's just pick, let's say, this point here. That point looks to be about 0.5. If we take a look at this, the height of g at this point, that looks to be, well, it's actually negative 2. So 0.5 is definitely not equal to negative 2. Okay, so it's not the negative of that. Now notice how, as f moves along to the right hand side, it's approaching 1. So let me write this out. As f keeps going to the left, f of x is approaching 1. But g, as it keeps moving to the left, g of x is approaching negative, infinity. Oops. Come on. Negative infinity. So we're actually it's impossible for 1, because remember, it has to be 1 is equal to negative 1 for there to be an intercept. But since f is approaching 1 and g is approaching negative infinity, it's never going to be equal to negative f. So f of a can never equal negative g of a. Okay, so we're not going to find any intercepts at this point. So we're actually finished with the 3 points, or the 3 guidelines that we can possibly use. But notice how the net result of that is only these 3 points. That is clearly not enough for us to use to graph the sum of these 2 functions. So we're going to actually have to start using some logic and reasoning. The first point that we can use is just find exact points that we can plot. For example, g at this point is 1, f at this point is 2, so 1, 2. Since we're taking the sum, 1 plus 2 is 3. We have another point we can use. Let's pick this point here. This looks to be about half, and that same point, f is equal to 3. 3 plus half is 3.5. Let's pick another point. This point here looks to be about a quarter. That's 0.25 in y. And the height of f at that same point looks to be about 5. 5 plus a quarter is 5.25, so it's a teeny tiny bit above, like so. Now let's move further to the left. As g, let's pick another point close here. That point, let's just say, is 0.01. At that same point, remember we're adding the 2 functions, f is equal to something very, very large. Let's just say it's 10. 10 plus 0.01, well, that's 10.01. But notice how that extra tiny little bit, that's actually very indistinguishable when we add it, isn't it? And it'll get even less noticeable as we move closer, and closer to 0. So what I'm trying to get at here is, as we move closer to 0 here, the sum of these should look like it's indistinguishable to f, because remember, it's f plus g. But as g gets closer to 0, like 0.01, f is a large number, let's say 10. Since it's going to be 10 plus something really small, it's going to look as if nothing is happening. So it should look like it's overlapping at that point. So now we have enough points to get this far. Click, it's going to curve like so. But now let's consider what's going to happen as we move to the right. Now let's say, for example, this point here, that's about 1.5 plus 2, that's going to be 3.5. So this point here is 1.5, this height here is 2, 2 plus 1.5 is 3.5. As we move closer to the right, that there looks to be about 1.4, this looks to be about 2.5, that becomes 3.9. We add them. So we already have these points here. Now, let's now think about what's happening to f as we keep moving to the right. As f keeps going to the right, f of x is actually approaching that asymptote of 1. So it's going to be 1 plus g. So let's say we pick some point here. So at this point, let's say f is 1. But at that same point, g looks like it's going to be, since it's a straight line, let's say just say for example it's going to be 4. So when we add the 2, it's going to become 5. As we move further to the right, f is still approaching 1. But g, since it's a linear function, it's going to equal 5. So 1 plus 5 is 6. When we move even further right, f is still going to approach 1. But g is going to take the next function value, which is 6. So 1 plus 6 is 7. Notice how since f keeps approaching 1, but g is a linear function, the net result looks more and more like a linear function itself. So what I'm trying to get at is it's going to curve like so, but as we move further and further right, it shouldn't curve more like this. In actual fact, as we've seen here, it should look more and more like a linear function. So as we move to the right, it should look more and more like as if it were parallel to g. So that there is what it should look like on the right hand side. Let's do that same reasoning on this left hand side here. Let's pick another point. Let's say this point here. That point looks to be about negative 0.25. At that same point, let's say it's 3. Negative 3. So negative 3, negative 0.25. Adding the 2 is negative 3.25. So it's a little bit more like so. As we move closer and closer to 0, g, let's say this point here, is negative 0.01. And at that point, f is a very large negative number. So let's say it's negative 10. In the exact same logic that I've shown here, negative 10 plus negative 0.01, that's going to equal, negative 10.01. Notice how that's actually indistinguishable. So in the exact same way as g approaches 0, we're adding smaller and smaller numbers to f. This means that as we move closer to x equals 0, it should look like it's overlapping f like so. Because remember, we're adding smaller and smaller amounts to f. It obviously curves like so. Now in the exact same way as f goes to the right, it's approaching 1. In the exact same way as f goes left, f is also approaching 1. That's what an asymptote is. So let's say we pick a point somewhere here. F is going to be, let's say, 1. 1 plus, at that point, let's just say it's going to be negative 3. 1 plus negative 3 for g. That's going to be negative 2. As we move again to the left, f is approaching 1, but g, since it's a linear function, the next point is going to be negative 4. 1 plus negative 4 is negative 3. When we take the next point again to the left, f is going to approach 1 once again. But g, being a linear function, is going to take the next value, negative 5. 1 plus negative 5 is negative 4. Notice how it's looking more and more like a linear function once again. So it should curve something like this. And then at some point, since f is approaching 1, and it's going to be 1 plus some negative linear function, it should look like a linear function as we move to the left like so. So that there is the sum of the two functions f of x and g of x. Now, to save you from making this video extremely long, I'm going to stop the video here, and I'm going to continue it in the next video for this example for the difference of these two functions. Hope to see you then. Best of luck.